Hello, my name is Peter Daniel. I'm a software development student and welcome to the presentation. In this video, I'll give you a bird's eye view of my IoT project, which is a simple smart aquarium system that uses PyCom, LowPy for development board, and MicroPython. During the summer, I took a course that I'm fascinated about, which is Internet of Things, or IoT, from Linnaeus University. As a part of the course, we are required to do a project, and after contemplating various project ideas, I decided to focus on the aquarium that I have at home. Okay, so what was the issue that I needed to address when it comes to fish tanks? Keeping your aquarium's pH and temperature level stable and in optimal range is paramount for the health of the fish and the maintenance of the tank. This means that I need to figure out a way to monitor their levels constantly and be alerted whenever a spike or a drop from the ideal range is detected. So my proposed solution was to first measure the pH and temperature level of the fish tank using sensors, then display the value on the OLED, then send the signal to the cloud, and finally get alerted whenever there is a spike or drop of the value based on real-time data. So the components that I use in this project are a LowPy for bundle that consists of a development board, expansion board, antenna, and a micro USB cable. And for building the electronic circuit, I used a breadboard and some jumper wires. In terms of sensors, I used an analog pH probe, a digital temperature probe, an OLED display, a piezo buzzer, and a resistor. And to power my project, I used a battery holder with an on and off switch and rechargeable batteries. And as you can see in this slide, both we have the schematics and the actual electronic circuit that I built. And I've mounted all the components in a plastic base that from my Arduino Q. When it comes to tools and frameworks, my IDE of choice was Atom because I'm familiar with it. I already had it in my machine, so the only thing that I needed was to install the PyMaker plugin to use it for this project. When it comes to wireless protocols, I used Wi-Fi, mainly because my project is part of a smart home and it's used indoors, but also because I don't have a LoRa or Sigfox coverage in my area. In terms of cloud platforms, I used both PyBice and Ubidots, which are low-code platforms. They use MQTT and HTTP respectively as their transport protocols. Okay, so now before we do a quick demo, um, yeah, things to know. The optimal range for pH in a fish tank is between 6.8 and 7.6, while temperature is between 24 and 27 degrees Celsius. So when the level of both the pH and temperature is ideal, a green light will be emitted from the built-in um, LED in the device, and the values would be displayed in the OLED. But if there's a spike or a drop from the optimal range, the green light will be replaced by red, and we'll hear a Super Mario Bros. Theme. So um, here is the demo. Okay. Yeah, so now we come to the data visualization part. This first slide shows the look and feel of the PyPy's dashboard, where you can see the received data here. Uh, but we have the signals here, and yeah, you can see the device location here as well. In addition, you could also get notified with PyBytes. For example, here you see battery level. So in my case, I'll be alerted whenever my battery level drops between 20%. When it comes to PyBytes, they only store your data for 1 month. But if you want to persist the data, PyBytes offers integrations to external services such as Amazon Web Service, Google Cloud, Microsoft Azure, or as I have done, and as you can see in this slide, you could integrate it with webhooks. This is the other cloud platform that I use, Ubidots STEM. Here I have two different images, one for the Ubidos dashboard that displays the pH and temperature indicators, and the other one is Ubidos events. And when the event is triggered, we'll be alerted via SMS or email. So we have two alerts here for pH and the temperature. And yes, as you can see in this slide, this is an example of an email notification that I got to alert me that the temperature level was spiked. Last but not least, I'll address some of the limitations in this project and the lessons that I've learned. When it comes to power consumption, like Wi-Fi is not as battery hungry as LTE, but it still consumes more battery power when compared with low range, low consumption wireless technologies like LoRa. So in order to remedy that, I'm using a battery holder that has an on and off switch, and it has 3 rechargeable batteries. So I'm using that to power my projects, and the batteries will be recharged simultaneously as well. Another thing that I really wanted to try but I couldn't was using LoRa, and the reason is because there is no uh, LoRa or Sigfox coverage in my near proximity. I've learned a lot in such a short period of time in this immersive course, such as MicroPython, the different wireless networks, um, transport protocols, and cloud platforms. It's one of the best courses that I have had so far, and it left an impression on me regarding the importance of IoT and the role it could play in making this world a better place. Yeah, well, that was all. Thank you for listening. I would also like to use this opportunity to express my deepest appreciation for Frederick, Francis, the guest lecturers, the wonderful TAs, the support students, and all my fellow students for making this course a delight. Thank you and ciao.